Hello, everybody. Today, I'd like to explain how to run AI development project without failure, or at least minimize the chances of doing so. The reason why I'd like to make this explanation is because we're getting a lot of requests, and most of them are quite similar. So, in order to save everybody's time, I'd like just to create this explanation and later share this with interested parties. Now, this is happening because some clients are starting their project with not experienced people and then coming to us asking to fix the failure. And for experienced people, the failure was just obvious from the very beginning of the project, but that's why people are getting in that pitfall. So I'll briefly introduce use cases, why that happens, and so on and so forth. So the first most important thing is you have to understand that there is a difference between regular programming and AI development. Despite they are using the same language, they are talking to different parts of the reality, and software and hardware are different. First thing is that regular programming, regular software development involves just writing explicit instructions and deterministic algorithms with absolutely predictable behavior. Now, the programmer dictates how the system should behave in all scenarios, handling predictable problems, exceptions, errors, and this means that the programmer roughly understands what will be done and the time of estimation for the project. In contrast, AI development involves creating systems that learn from data rather than following predicted rules and predefined rules. And this requires training models, fine-tuning algorithms, and working with complex data sets. Sometimes you have several models and you have to join them together, creating different branches of models, and then again combine the results of outputs of different models, and so on and so forth. On the other hand, there is another thing is where obtaining the data set could be quite costly. Now, you have to check the hypothesis first, right? So you've got the hypothesis that data contains particular information, and you have to extract that information out of the data. But the data itself is expensive. And rather than buy it and spend a lot of money, or there are another tips and tricks which you can use in order to avoid it and get victory with the less blood. Also, sometimes the metrics of the model are signaling that accuracy is fine, intersection of union is fine, but the model doesn't work, or vice versa. The metrics are climbing up quite slowly, but the intuition of experienced fella could tell you that everything is going all right and that the light is there in the end of the tunnel. And this relies also on different techniques, such as visualizations, such as debugging techniques of the dataset itself and the model as well. This matters because in regular programming, it's very easy to fix the error. Well, if you are experienced in the programming, then you just locate it, see the line of code causing it or behavior of the code causing it, and then you just change it and the problem's done. And there is no bug anymore. You also could write tests for it in order you have different behaviors. Then the tests are going to reveal it, and again, easy to fix, easy to predict. In contrast, in AI, bugs can arise from the data itself. The model could have a bug in it. For example, when you jump between different dimensions of the tensors, or you apply custom loss function, this could lead to some easy extractable information about the error. This is a real life use case when we had something like 100k images and only 5 images were breaking the model, and it was quite hard to understand. And I think this what gives the value to experienced AI developer, that like overcoming such obstacles is just giving the experience you would never ever get anywhere, and nobody can teach you, because again, 5 images and you have to understand what's wrong with those 5 images. Although they look absolutely normal if you just look at them with normal eyes. Another thing is open source code challenges, right? So this is another part. When, for example, you've got the theory that you have to predict particular things on your data set, and you find a paper on the internet, and luckily the paper has a code base on a GitHub, fine, even better. And then they give you a link to a model to download and run on your data. Now, you open the paper and everything looks absolutely fantastic. Everything is there. All metrics are in the sky. Like accuracy is like literally the one, not even 0.9999 and so on. And then you just run through your images or your other things, either time series, whatever, and you are getting just like rubbish, like 50-50 random results. That's the big difference between regular programming and this thing here, AI open source code repositories. This means like if in regular programming, usually you just use plug and play things, and if something doesn't work, you just like find the problem, fix it, and you're good to go. Now, here is very different story, because people were using data, you never know what they were using, then you are getting their model, you never know how did they train, they just show you the metrics. And again, when people are writing papers, they are biased to show you the best results, right? So I'm not saying all of researchers are doing so, but I just admit there is a bias, and you have to understand the bias exists. And this bias forces them to just cherry pick the best images, the best metrics, the best use cases, and display in a paper. And that's why in more than half cases, it doesn't work when you just download it and try to run it on your data sets. And another interesting thing is data sets themselves require a lot of work. So it's quite funny to see how developers who want to jump in AI development, they are always saying, we are going to train neural network. We are going to train neural network. And to be honest, I was something like that as well. I was thinking training neural networks is what AI developer does. Now, 90% of the time, it's a data set analysis, preparation, dataset debugging even. So a lot of work has to be done before you even touch model architecture. Most of the times, this is the main challenge, that it's not enough data is dirty, whilst badly organized and so on and so forth, or contains particular artifacts. So this is another thing where experienced UI developer knows how to do, right? Because they spent, I believe, a few years doing so compared to just a regular developer. And what happens then, right? So you are getting misalignment of your expectations. While you are expecting that results are going to be in a fixed amount of time with a fixed amount of money, usually it goes far beyond any reasonable limit, and no wonder, because you are getting such obstacles which couldn't possibly be visible to you before you begin. You are only learning in a hard way that the things are not that flush and rosy as you were thinking they are. And also, there are development pitfalls as well, where the important part here is to understand is deterministic programming is making your psyche to be inclined towards perfection, because you learn that your code has to be perfect in order to perfectly work. This is absolutely not the case in AI development, because you are dealing with probabilities, and your mind has to be reprogrammed in a way to love probabilities, and you have to create your model which will probably work, and the probability has to be higher and higher, and you have to know how to clean this level. Now, the problem here lies where regular programmer thinks they have to put everything on, they have to put everything spot on, and every single detail has to be fine and well written. And what happens in reality, they focus on unnecessary development tasks too much and waste a lot of time, while you have to accept that the failure is a part of a process. And the model could and would fail, and the probability of that much higher than you expect. And it's similar to the design work, where design is creating a concept or even 2 or 3 concepts and then presents to the customer, and the customer decides which few concepts they want to throw out, which to accept. And then out of those concepts, further development happens, design development. In our case, AI development, model development, and so on and so forth. So you're also testing different concepts, different approaches, and you always accept that model won't work or will work with less performance that you do expect. We have particular use cases with that. The first thing was the cancer detector development failure. So what happens there was the model was training inaccurately, delays, timelines, loss of funds, and so on and so forth, and trust and so on. And it was several people team and so on. And the important part that the previous team could not recognize that the dataset had hidden artifacts on those images. That was literally the pain. That's why they failed, right? They were just going in circles and tearing their hairs out to try to understand what's wrong. Well, in reality, if they could use particular visualization techniques, they could recognize that the model learns not on what people would like it to learn, but it finds particular artifacts. In reality, it was like the white background was having a particular gradient, and that gradient was the same everywhere, and the model learns it. And in order to find it, these gradients, you have to like apply a visualization technique, and then you see it's like a traffic light for you, just flashing red that this is wrong, this shouldn't be there, and the model shouldn't learn it. Right, so this how it was fixed, and so on and so forth. Well, another case was the X-ray, it is recognition failure. The regular developer could not foresee such medical data preprocessing. So basically, what was the story was somehow similar to the previous one. It was just like 10 bad images of those X-ray teeth among like 100K data set. So what happened there? I don't know why, but those images, they were having different gradients than the previous ones, and the gradients were hidden because visually it looks the same, but one of the channels, pixel values, they were having particular values, and those 3 images, I don't know, maybe camera was broken, maybe, I don't know what happens with those few images, but when they were pushed through the model went nuts. And the weights in the model, for some reason, were just like moved towards the entropy, and the model performance didn't work. Right, extracting those rubbish images helped a lot, and the model is working well now in production. What happens? Why hiring experienced ones is cheaper in the long run? Because why I'm saying this, because like to hire an experienced ones is quite costly. Regular programmer costs a bit less, and project manager or anybody who could take this decision, they could say, right, this programmer could just read the code and implement the code, and everything is going to work because it's the code. The code is the same. It's the same like language, like Python, C# or whatever. This leads to problems that the experienced AI developer knows how to navigate complex challenges, like, and minimize the error, like, because they've got this thinking about probabilities and improbabilities. They're thinking in probabilities. And here, what happens also is a faster time to market, because again, we create a model and we don't understand how it's going to behave on the market. Then we just push it on and then see how market behaves and extract information out of it and then just use it or scrap it. Then, because experienced developers do know, like AI developers, they do know how to use data cleaning, then how to create synthetic data set, how to Also, synthetic data sets, complicated part of the topic, and maybe it's going to be covered in the future ones. But the problem here is sometimes it works, sometimes it's not, and you have to know what to look for in order to debug it. Another thing is the client use case. So what was happening here is, again, the complexity of the project was like flying through the roof. The problem here was that because the initial model didn't work, didn't show the results, the client and the engineering team, they decided that they could use this model in order to get some output out of it, and then put another model on the top, and then third one, and so on. Also, they were using simple computer vision algorithms, which needed, as they were thinking, they will help them to organize the outputs, and then the model is supposed to, like the last model in the chain, to recognize, and so on and so forth. Now, what happens in the end? In the end, the system was too complex, and because of that complexity, it was very hard to navigate appropriate. Another client use case, what we've got was, it was a furniture replacement of images, right? So what happened there was initial system created by other people was too complex. It had far too many moving parts. It was absolutely impossible to debug because outputs of some models were used as inputs for other models, but I don't have anything against it. However, in this particular case, it was unneeded complexity. So we needed to scrap all that because models themselves, they were questionable. And due to data diversity, this also led to a failure. So in order to overcome it, you have to create your system relatively simple, that you don't spend a lot of time debugging it, understanding what happens under the hood. You have to see what's wrong with the model straight away. And if it's not what you expect, then you have to have a nerve to scrap it. I have to say a few words here that, of course, if people don't know what they do, or they do not have this puzzle about how to do AI development right in their head, then people from the business division, they are just going to pour endlessly money in a team before, and then just it never ends because the results are never there. And of course, this puts risk on companies' future investments. That's one thing. Another thing, management would think the AI is not a real thing, it's not working, and they just lose hope in it, while other competitors, they would go a successful path and win this battle. So benefits of MVPs from expert teams, as you can see, is you could quickly understand what to expect, right? Because, well, basically business is just a prediction and using this prediction to make a profit. Well, this is what business is, basically, right? So quicker and more precise predictions you can make and test them, the better your competitive advantage is. So if you are able to create MVPs fast, then you could allow your experts and see early results, market reactions, and get stakeholders buy-in sooner. Also, scalability. Quite common, customers are not realizing the cost of training and production, and this is quite an important thing as well, on the other hand, because not just getting the model and make it working, but also you have to understand how much does it cost you, right? So, well, first, in order to obtain the model, you have to train it. And to train it, it's quite costly because you have to have particular infrastructure for that. Now, later, you will be running an inference server, and this is also very different from the regular server because it has to have a GPU connected to it, then it has to be able to run multiple requests at a time, and this is different story compared to regular applications. Again, experienced AI teams understand better how to build flexible, maintainable models, right? So it has to be sort of predefined before the project starts, because you have to have your model storage, then you have to have ability to deploy your model in production fast. Once you're happy with the metrics, sometimes You create a loop development when incoming information is retraining your model, and this model has to go into production as soon as metrics are fine for the model. And in order to conclude here is we are aiming to create a particular successful AI products ourselves. I hope you find it interesting. So thank you very much for your attention, and I hope it will help you to run successful projects yourself.